take off, we'll be measuring the reinforcement for the beams. We have the plan here, the plan and the section. The way we can see the beam, from center to center, its length is 2600. We are told that we shall use stirrups, or the rings shall be made of R6, and they shall be 150 millimeters center to center. We are told that this reinforcement here at the top, it's 2T12, that's its name. Then this one at the bottom, it's 2T18. The measurement of this column is 125 by 125 column. The ground beam has, this one, it's a ground beam, the beam that we are talking about. The concrete cover is 25 millimeters. Then we are told that the cross section of the beam, the width of the beam is 125 millimeters. Then the depth of the beam is 375 millimeters. Now we want to measure the reinforcements that shall be used in this beam. First of all, as you can see in the cross section here, we shall be having reinforcement here, 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 and here, and they shall be running like this. The reason you can see them like this is because we are seeing them from here. All right, so we shall have 1, 2, they shall be 2. Here it's 1 and another one the other side. So here, here, here. You see, we have 2 of this, 2 of this, then they are tied together by rings. Here we have a stirrup, another one after 150 millimeters, another one after 150 millimeters, after that way until we get here. Okay, so how do we measure for these reinforcements? First of all, we need to measure these longer ones. We know what is the length of each of those 4 reinforcements. We shall start with these 2T12, the 2 of them. What will be the total length of those reinforcement bars? So they shall be from here to here. Then we add the bend. Then we add the bend. But if you can see from our diagram here, we are given from center to center it's 2600. And these reinforcement bars are going past the center. So how do we calculate for their length? We are told that the concrete in the column measurement is 125 by 125. So if it is 125 by 125, meaning from the center here to the end is 125 divided by 2. If we can take the dimensions from center to center, which is 2600, then we add a half of 125, a half of 125, we can get the total length that was to be for the beam. When we get the total length, we shall deduct the cover of concrete here and the cover of concrete to get the length from here to here. Then we shall add the bend 2 times. Then we shall have got the total length of reinforcement. Remember, when we are calculating the length of this bend, we usually calculate it with the formula 5.5D. So let's go to the taking off. For the taking off, you see, this is the reinforcement bar that we are talking about, 2T12. The length of that bar is 2.6. Then we want to add what is remaining, the halves that are remaining in the column, so that we get the total length of the beam from end to end. When we add a half of 125 both sides, it shall be 0.125 plus 2.60. So the length of the beam from end to end is 2.725. Then we deduct the cover. The cover is for 25 millimeters. When we multiply 25 millimeters times 2, it's 50 millimeters. So 2.7525 deduct 50 millimeters, we shall get 2.675. That is the length of the reinforcement bar, which is straight. Then we add the bend. The bend is 5.5D, and there are 2 bends. So it shall be 2 times 5.5 times diameter. The diameter is, you see, we are told it's 2T12. Alright, so T12 is the size of the reinforcement bar. So the diameter of that reinforcement bar is 12 millimeters. So to get the size of the bend, it's 5.5D. D is 12 millimeters. So 2 times 5.5 times 0.012, we shall get the length of the bends of the 2 sides. So when we add the 2, we shall get 2.807. That is the total length of that reinforcement bar. So say 2.80. So while you're booking it, it shall be 6 units, because we had been told we are talking about 6 units of beams. So here we shall be taking off 6 beams. All right, so we shall be taking off 6 beams. So it shall be 6 beams, 2 because we are told this reinforcement bar at the top, they are 2 T12. All right, 6 times 2, 1 reinforcement bar is 2.80. So the total length of the T12 bar is 33.60. We go to the other one, which is now the bottom one. All right, it's called T18, and there are 2 in number. What will be the length of that reinforcement bar? So the length from center to center is 2.60. We add what is remaining in the column so that we can get the length of the beam from end to end. So it shall be 0.125, because we will have taken a half of 125 times 2. So we have measured this one from end to end. Now, to get the length of the reinforcement bar, we have to deduct the cover of the concrete. We had been told the concrete cover, the measurement is 25 millimeters. So 25 millimeters in meters, it's 25 divided by 1000 times 2. So the covers, it's 50 millimeters. So if we take this one minus this one, we shall get the total length of the reinforcement bar where it's straight. Then we add the bend. The bend, to get the size of the bend, is 5.5 D on either side. So 5.5 times diameter, you see this one is T18. All right, because from the plan we can see this one is T18, meaning the diameter of this reinforcement bar is 18. So to get the size of the bend, we shall take 5.5 times diameter, 18 millimeters, and there are 2. So we shall get 0.198. So if you take this plus this, you get 2.873. So say 2.87. So there are 6 units, 2 reinforcement bars. Each reinforcement bar is 2.87, and the total we get 34.48. These are 34.48 meters. These are T18, not T12. Here there is a mistake, T18. So we go to the stirrups. The stirrups are the ones that will be tying the reinforcement bars together. As you can see here, these are the stirrups, the rings. They start from here to here. So we need to know how many they will be, having a spacing of 150. Then what is the length of one stirrup, so that we can get the total length of the stirrups. So for the stirrups, we can see this one is 125. You know the size of the beam, it's 125. Then the depth is 375. Remember, the stirrups will be inside the beam. They should not touch the outside. It is surrounded by a concrete cover, because we should not be able to see the reinforcement when it is inside the beam. So how do we calculate the length of the stirrup? The length is 0.375. We shall deduct the cover. A cover of 25 down here, 25 up there. So we shall deduct 50 millimeters. We get 0.325. For the width, this way, it's width, it is 125. We deduct 25, we deduct 25. We get the width as 0.075. So how do we get the perimeter of all going round? We shall take the length, then we shall take the width, then we shall add, then we shall multiply by 2. All right, so this one plus this one, we shall get 0.4. Then we multiply by 2 to get the total perimeter round. Then we need to add the anchorage. You see, a stirrup usually have where it overlaps, things like this. This one is the one that we call the anchorage. To get the length of this length that is overlapping here, that anchorage is 24D for 1. So to get the length of that one, we shall take 24 times the thickness. It's what for one is 12D, the other one 12D. So the total is 24D. So to get the total length of that anchorage, we take 24 times the diameter 0.006 because it's 6 millimeters. So we shall give an extension of 0.144. So we shall take 0.8 plus 0.144, we get 0.944. So the total length, say it's 0.94 if you round off. So how many number of stirrups do we need? The total length from center to center is 2600. The column, a column is 125 millimeters. So we need to know where the stirrups start and where the stirrups end. You see, the stirrups do not start at the end here. They start where the column ends, around here, and where the column ends. So they are distributed here. We cannot tie a stirrup inside the column. It's only inside the beam where there is no column. These ones, the loops are the one which enter into the column. So from here to here, it's where we're distributing our stirrups. So we shall take 2600. Then we shall take a half of 125, we deduct. A half of 125, we deduct. So it shall be 2600. Then we deduct a half of 25 times 2. It's 125. So 2600, we deduct 125. We shall remain with 24 to 47. This one. This one in meters, deduct this one in meters, we get 2.75. So this one is where we shall distribute the stirrups, and they have a spacing of 150. So we shall take 2475 divide by 150, then we add 1. We get 17.5, say 18. So this one shall be 6 millimeters diameter MS stirrups. So it shall be 6 units times 18 stirrups. One stirrup, the length is 0.94. So we shall get the total length is 101.52. So the total length shall be 101.52 MR6, spacing of 150. And thus we are done with the reinforcement in the beams. We are going to take off the formwork in the beams. We shall use this plan and the sections that we have. For the plan, we have this rectangular building. It has a beam going all around. The length of the beam from center to center is 4500. The width from center to center is 4000. We have section A and section B. The cross section for the beam, the width of the beam is 200 and the depth is 350 millimeters. Beam A 12, beam A 12, it's from center to center 4000. So it's from here to here. So you see this beam here and this beam here, we have to give them a name. The first beam here, we shall call it A12. A, because it's the first one, it's coming from 1, 2. Here is you shall name it B, coming from 1, 2. Alright? Here, this beam for the length, the first one we shall call it beam 1, A, B. Alright? This one we shall call it beam 2 for A, B. And so, this is what is shown here. So, we are told now to take off or to measure for the formwork in the beams. You see, this is a house. The beams are interconnected. We have formwork that we shall do on the sides to prevent the concrete from pouring, and it shall be side, then inside, outside, inside, outside. So for the external dimension, just like the external dimensions is r, we shall have formwork. And just like the internal dimensions are, we shall have formwork. Now, here you need to consult the guidelines that you use in your country. For example, in Kenya, we use the SMM7, which shows how formwork should be measured. So in Kenya, we measure it using linear meters. But in some countries, we just measure the formwork using the area. You see, like here, the formwork will be from up to down. So you shall take this area, the depth of the formwork shall be 0.35, then we multiply by the total length, we shall get the area. And we multiply by the total length, we shall get the area. So you just consult the guidelines, then they will guide you what should you use, linear meter or square meters. In our case today, we shall use the square meters. So, for the formwork, we will say sawn timber of 38 millimeters thickness to outer sides of beam 1 AB and 2 AB. We have said that 1 AB and 2 AB, they are along the length. Alright? So when you are measuring this formwork and you are measuring it in area, we need to get the dimensions from the end to the end. Center to center is 4500. To add this one, it shall be a half of 200. Then we add a half of 200. So a half of 200 is 100. Here it's 100. So it shall be 4500 plus 200. We get 4700. We come to the wing. 4700. 4500 plus 200, 4700. So what is the area of the formwork in the section 1 AB and 2 AB? Alright, so it shall be 2, because there are two sides, 1 AB and 2 AB. 2, we multiply by the length of that beam, it's 4.7. Then the depth is 0.35. So the total area of the formwork is 3.29 meters squared. Alright? So we shall come to sawn timber of 38 millimeters. Why are we saying 38 millimeters? It's because the timber measures 38 millimeters. You have to specify which timber you're using. Alright. Thickness to inner sides of beams. You see, this one is inner side. This one was outer side. If we are talking about the inner side of beam 1 AB and 2 AB, we are still talking about these beams. We have measured outside here. Now we are measuring inside here. Alright? So, when you are measuring the inner sides, we shall take the dimensions from here to here. Okay? This one was from here to here. But for the inner sides, from here to here and from here to here. So if it was 4500, we shall have to deduct 100 here and 100 here. So 4500 deduct 200, 4300. That is the length here. Then you have 4300. You multiply by the thickness. You'll get the area. Then you multiply times 2. So there are two sides of two inner sides. Multiply by the length of 4.3 on the depth of 0.35. You get 3.01 meters squared. Then we shall go to sawn timber of 38 millimeters thickness to soffit of beam. Soffit is the bottom side of the beam. We need to do formwork there. So what are the measurements for the bottom side of the beam? So we are still talking about section 1 AB and 2 AB. You see, when we have this diagram here, we have been shown these beams here. When we are placing the formwork below there, and remember here at the corners we have columns, we will only place below from here to here, because at the corners we have columns to hold the beam. So we cannot place formwork on top of the column, because we want them to come together. So we shall only support below the beam. So from here to here it's 4.3, right? So we shall take about 4.3, then we multiply by the width, which is 0.2. So it's here. We have two beams, 4.3 and 0.2, the thickness. So the area of the formwork at the soffits of the beam is 1.72 meters squared. Now we shall go to the other beam, which is A12 and B12. So to get the area of the formwork on the outer sides of these beams, how do we calculate it? Remember, we are given the length center to center. Now we want it from end to end. 4,000 plus a half of 200 plus a half of 200, we get 4,200. All right. So for the outside part shall be 4.2. Then we multiply by the thickness, which is 0.35. Then we shall multiply by 2. 2 times 4.2 times 0.35, you get the area of formwork is that. The other one is sawn timber of 38 millimeters thickness to inner sides of the beams, section A12 and B12. So it shall be, the length is 4 meters. Then you deduct 2. Let's look at it. From the drawings, we want this inner side of the beam from here to here. So we have center to center 4,000. You deduct a half of 200, a half of 200. You deduct a half of 200, 100 times 2, 200. 4,000 minus 200, 3,800. So we shall have 3,800 times 0.35. You multiply by 2 beams. All right. So we go to the soffits of the beams. We only support the underside where there is no column. So where there is no column is from here to here, because the columns are the corners. So the length of the formwork from here to here shall be 4,000 minus 200, 3,800. So 3.8. Then we multiply by the width of the beam, because you're supporting the bottom part. It is 200, so it's 0.2. Then we multiply by 2. So it shall be 2. You multiply by 3.8 times 0.2, you get the area of the formwork as such. So if we want to get the total area of formwork, we shall begin by taking 3.29, 3.0, 1.72, 2.94, 2.66, and 1.52. So we shall get the total area of the formwork in meters squared. So how do we put them in the bill of quantities? Remember, the bill of quantities has an item number, the description, the quantity, the unit, the rate, and the amount. So we shall come and write its item number 1 in formwork. Sawn timber of 38 millimeters thickness for beam. The total quantity, we shall put it here in the bill of quantity. The unit is in square meters, so we shall come and add the rate and add the amount. All right. So once we add, if there are many, we could get the total bill here. All right. So we are done with taking off the formwork in beams. We are going to take off the formwork in the beams. We shall use this plan and the sections that we have. For the plan, we have this rectangular building, it has a beam going all around. The length of the beam from center to center is 4,500. The width So we will be taking off concrete work for the beam. This is a house. It is rectangular in shape. Then at the corners here we have columns. At corners we have columns, though you cannot be able to see them. Then the beams are going round the house. It's like a lintel, the way it goes round the house. Then you're told to take off for the concrete in the beam or to measure it. You're given the cross section of the beam AA and BB. The beam is starts from end here to end here. Then this one again, it's the length. If we want to measure the width, we will not start from here again because the concrete that is in the length has already been accounted for here and here. So the concrete that you can only measure in the width is from here down up to here, and from here up to here. Alright, so now we want to measure the concrete in the beams. So how do we measure the volume? The concrete in the beams is measured in volume. How do we calculate the length on the length side and the volume on the width side? Using this diagram, we shall start from here to here, which is 4,500. You see the 4,500 we are given, it's from center to center. But now, because we will not be using the center line, we will have to calculate from end here to end here. If the thickness of the column is 200, if up to here it's 200, if up to here it's 200, from here to here it's 100, from here to here is 100. So to get the total length from here to here, it shall be 4,500 plus 100 plus 100. Alright, so it shall be 4,500 plus 200, which is 4,700. What about the length for the width? We shall take center to center is 4,000. So from here to here, it shall be 4,000, deduct 100 to get outside here, to deduct 100. So it shall be 4,000 deduct 200. We get 3,800. So when we come to feeding them in the takeoff sheet, we shall say concrete work. The mass concrete for section 1 AB and 2 AB, the length of the beam on the length side is 4.5 center to center. The column size is 200 by 200. The thickness of the beam, the thickness of the concrete is 350 millimeters. The breadth of the beam is 200 millimeters. So the length of the beam, the total length, the way we have calculated it, it is 4.5. It was center to center plus a half of 200. A half. You see, a half. Why are we saying a half? Because it's at the center. To get the we are saying a half because it's from here to here, here to here. This is a half. A half times 2, because it's this side and this side, then times 200. So it shall be a half 2 times 200 millimeters, it's 0.2. So the total length of the beam is 4.7. So when we come to calculating the volume of the concrete in the beam, shall be 2 beams, because it is one on the length, another on the length here. This one is one beam on the length side, the other beam on the length side. Okay, so it shall be times 2. Okay, so we have 2 beams which measures 4.7, 0.350 and 0.2. So the total volume is this one. Then we go to the mass concrete in the other one, section A 1, 2 and B 1, 2. So why do we say there's section A12 and B12, 1AB and 2AB? This is because if you look at the section that we have here at the plan, you see this one is section A. Section A can be on AB. Then we also have another section here, A, which is on AB, on the other side. So this first section, we shall call it section 1 for AB. Here it shall be section 2 for AB. When we come to the wind side, when we have a section here, this one will be section 1 for 1, 2. So to avoid that section 1 for 1, 2, we can say section A for 1, B. The other one, because it's the second one, we can say section B for 1, 2. Alright. So the AB is on the length side. The 1, 2 is for the wind side. So how do we calculate the volume of concrete on the wind side? The length of the beam is 4 meters. The column size is 200 by 200. The thickness of the beam is 350 millimeters. Breadth of the beam is 200. So what is the length of the beam that we shall use? We shall take 4 meters. We shall deduct a half of times 2, a half 2 sides of the width, and the width that we are talking about is 200. Yes, as we talked about here, if you look at the wind side, we have taken from here to here, it's 4,000. So to add to deduct, because we will need from here to here, we shall deduct a half of 200 times 2. That's why we are saying a half times 2 times 200. All right. So we get the total length of the beam that we shall consider is 3.8. So what is the volume of the concrete in the two beams? It's two beams whose length is 3.8. The thickness of the concrete is 0.35 and the width of the beams is 0.2. So the total volume of that concrete in the beams is 0.532. If we add the two volumes of concrete, we shall get 1.19 meter cubic. So how do we enter that into a bill of quantity? Showing the concrete work. We shall come to the column showing the bill of quantities, where beams are. We always have the item number, the description, the quantity, the rate, the unit, the rate, then the total amount. So we shall write concrete work, mass concrete for beam mixed grade to be determined, because we are not told in the diagram, yet the structural engineer should have given us to be determined. The total volume is 1.19 meter cubed. So we shall come and do the rate per meter cubed here. Then we shall get the total amount for the concrete in the beams. All right.